Dynamic reconfigurable systems are gathering an increasing interest from both the scientific and the industrial world. The need of a comprehensive framework which can guide designers through the whole implementation processes is becoming stronger. Just to consider one characteristic of FPGA devices, there are several techniques to exploit partial reconfiguration, but few approaches for frameworks and tools to design dynamically reconfigurable systems. They don't take into consideration both the hardware and the software side of the final architecture, and in general, they cannot be used to design systems for different architectural solutions. We know that FPGAs provide a large speed up and power savings at a price. Days or weeks to get an initial version working, multiple optimization and verification cycles to get high performance. Furthermore, these systems are getting incredibly complex. Normal mortals cannot easily program massively parallel systems. This is all turning into an increasing productivity gap. Considering the technology improvement and in measuring it as an example in number of logic transistors available per chip, we can see that the way in which it is growing is higher with respect to the productivity in using it. In other words, we are wasting potentialities made available by the chip because we are not able to properly manage them into our final design. This is definitely wrong. This has to be avoided. That's a huge field of research right now. This is not true only for universities and research centers, but also for companies themselves. As an example, we can see that Xilinx, even if it is a EE company, even if they are the one producing the underlying technology at the basis of our systems, they are interested a lot in designing the most advanced and user-friendly toolchain. And this is not just something they are doing today. This is part of their culture. Back at the beginning of the century, around 2001-2002, I was a master's student, excited about the idea of using FPGAs to implement my runtime adaptive system. It was awesome. I was doing it by writing VHDL code and by using Xilinx Integrated Synthesis Environment, or ISE, to synthesize it and to generate the final bitstream. But I was curious. I was working with an FPGA, the Virtex 2 Pro, that I knew that it was embedding a Power PC 405 processor, and I was willing of using it. But doing it in pure VHDL? Well, it wasn't easy. Fortunately, I hadn't to wait for too long. That was also the time in which Xilinx was working to the Embedded Development Kit, or EDK. That was huge. That tool changed my entire design experience. EDK was helping me in creating an embedded system via graphical user interface just by instantiating the necessary IPs and in connecting them. Well, it wasn't that easy, but just let me remind it in that way. This is a perfect example of a company effort in trying to reduce the productivity gap. Furthermore, once that you have a system based on a processor, you need a toolchain to allow you in getting the best out of the underlying infrastructure. And that was exactly the Xilinx SDK framework. With EDK and SDK, there was also one more interesting news: the release of the microbase softcore. The advent of the microbase was terrific. This was opening the doors to a set of completely new research challenges and possibilities. We had all we need to design and prototype multi-core systems. And remember, we were now around 2005-2006. These tools had improved a lot over the years. But there was something new waiting to be included, waiting to be explored, waiting to be used to change everything. High-level synthesis, also known as HLS, can be seen as an automated process to move from an algorithm description of the desired behavior to a digital hardware implementation of that behavior. HLS has been around for a while. Early commercial examples developed by Synopsys were already around at the beginning of the 90s, but only in the second decade of the 21st century we can see a real explosion of these technologies. On July 2012, we can read on the Electronic Engineering Times page: the folks from Xilinx have just made available the first public release of their next generation design environment. The Vivado Design Suite 2012.2 is now available to all IAC Design Suite customers. This was going to mark an epoch. Not only Xilinx was working on including HLS solutions in their frameworks, but Altera too with their OpenCL initiative. This was definitely marking the beginning of a new era. Consider the advancements in the FPGA technologies and the increasing interest in coupling them with host solutions to implement complex heterogeneous distributed system, cloud infrastructure. the need for a simplified host integration and automated infrastructure creation was going to be the next big thing. Xilinx was ready to face these new challenges, and they released 3 new tools: SDSoC, SDNet, SDAccel. We're going to hear more about them, especially with respect to the SDAccel development environment.